use the tangent sum formula, break it up, and then just fill everything in. So let's start doing this. Quadrant. So we're in quadrant 3, right? And we're given cosine, which is the x over. So I'm going to put negative. I'm going to put negative 2/5 like this, and then I'm going to write x over r, right? And the negative you could look at as the top or the bottom, right? Which is it going to be for us? Top, because the r has to be positive. The x here would be negative. So negative 2 over 5 is my x over r. That means the x coordinate, let me draw my angle. The x coordinate I know is negative 2, right? The y coordinate I don't know yet, but I know the radius is 5, right? From here to here is 5. Pythagorean now, right? X squared plus y squared is r squared. X was negative 2, so negative 2 squared plus y squared is r, which is 5 squared. Four plus y is 25, which means that y is equal, oh, I forgot to put my squared here, sorry. Y squared. Y squared is 25, take away 4 is 21, right? And now take the square root on both sides. So y is plus or minus root 21. And is it plus or minus? Negative. Negative, right? Because we are in quadrant 3, and in quadrant 3 your y coordinate has to be negative. So we're going to say y is equal to negative root 21. And now that I have that, I can tell you what sine, cosine, tangent, everything, right? So let's go ahead and put that information down here because we'll probably need it. I know sine of theta. Why'd you do that? Don't distract me like that. Sine of theta is, what was sine?
Negative.
Good. Root 21 over 5, right? And then cosine theta, well that I shouldn't mess up, right? Because that was given to me. Negative 2 over 5. And then just in case we need it, tangent theta will be the y coordinate divided by the x. So negative root 21 over negative 2, right?
So would it be positive?
Yeah, so we just make this positive. Root 21 over 2. Oh, you don't have to pick that up. Oh, never mind. Oh, there we go. Got it? Sine, cosine, tangent? All right, we've done this, right? This is done. Sine is negative root 21 over 5. Let's see this part B. See the part B. So for part B, we have sine of theta minus pi over 6, right? That's what we're asked to find. According to our formula sheet, right? According to our formula sheet, this is equal to sine of theta, right? You're looking at this as being like alpha and beta, right? Alpha and beta. So it's sine this one, cosine of that one, right? So cosine what? Pi over 6. Okay, plus or minus?
Is it pi over 6 or negative pi over 6?
It's positive because we're looking at this formula as being alpha, right, minus beta. So when you're asking what beta is whatever that is without the minus.
Okay.
Good question. Everyone see that? So sine of alpha cosine beta, then what? Minus. Then cosine, in this case theta, right? And then sine of the beta, which is pi over 6. Good. So this is a little different than the last problem, right? Just a little bit. Like we don't have, in the last problem we had two things we had to draw, right? Here we only have to draw one thing. And here, sine of theta, we found out what that was, right? This was negative root 21 over 2. But I'm multiplying that times cosine of pi over 6. That you have to know, right? Luckily they gave us, notice all these angles they gave us are angles we know. So cosine of pi over 6 is remember where you are. Pi over 6 is here, right? Cosine's which coordinate? Is that a question? Or are you? Question? What's your question?
Is it, I thought it was negative 21 over 5.
Did I not? Oh, I put 2. Sorry. I don't know what. Yeah, I put this for some. Well, no, I didn't know what I did. I screwed up. All right. Thank you. That's sine. Sine theta. Okay, now cosine of pi over 6 is the x coordinate here, right? Which is root 3 over 2. Okay, minus, now cosine of theta. Now that we did, right? Cosine of theta is this, negative 2 over 5. Times, now sine of pi over 6, that's the y coordinate here, right? Which is a half. Notice on both of these, they have the same denominators, right? 10, 10. So let me see. These two together, hey, what's root 21 times root 3? Can you put those together into one root? Yes, and you will multiply what's underneath them. So this will be negative root 63 over 10. And then look at this minus minus, see that? I'm going to make that a plus, and that'll be 2 over 10. And I cannot combine those together, so that's going to be negative root 63 plus 2 over the common denominator of 10. That's it. Questions? Comments? Complaints? No?
Okay, I see it.
You sure?
Yes.
All right. You feel like you could do the others? Do you understand what you do? Yes.
In other instances, when we had two square roots, there were some other instances when we weren't able to then multiply them together.
Well, I think we were adding them, and that's why we didn't put them together. Yeah, so we have this. If you ever have square root of a plus the square root of b, you cannot combine these together. All right, that's what it is. But if you have square root of a times square root of b, then that will become square root of a times b. That you're allowed to do. All right, let's do part C. For part C here, cosine of theta plus pi over 4. I'm going to use the sum formula for cosine, right? And remember, for cosine, in the formula, it's the opposite of the sign. So if we see a plus there, it's going to be minus. So this should be, who wants to tell me what this is? Like, just read it out.
Cosine theta.
Cosine theta.
Pi over 4.
Is it sine?
Sine.
Did you say cosine or sine?
Oh shoot, it's cosine.
Cosine. Okay, so cosine, go ahead, pi over 4.
Plus.
Plus or minus?
Plus.
It's the cosine one. Remember, the cosine one is the one that's opposite.
Minus.
So minus
Sine theta.
sine theta,
Sine pi over 4.
sine pi over 4. Good. Yes? All right, now we know all these values, right? Cosine theta is -2/5. Cosine of pi over 4 is the x-coordinate at the angle pi over 4, which we all know now. Do y'all feel like y'all are getting better with the unit circle yet, or no? Still? Some of you give me that. Sanat, why are you giving me that look? Are you not feeling better about the unit circle yet? Getting there? Okay. Sine of theta is -√21/5, and then times sine of pi over 4, which again is √2/2. So here we'll be able to put these roots together, right? These roots can go together. That we can just put side by side. So let's do this. We're going to have -2√2/10, and then over here, two negatives again become plus. And then I'm just going to say √42/10. And yeah, see here we cannot put those two together. Right, so we're just going to go -2√2 plus √42/10, box it up, be happy, move on. All right, I'm going to leave the last part for yourself to do. You understand you just use that formula for this, right? This would be tangent of that minus tangent of that over 1 plus tangent of that times tangent of that, yes? No? Well, okay, you want me to? I will. How about I write it down? I'm not going to take it the whole way. I'll write it down. Okay, tangent of theta plus pi over 3. So I'm going to use my formula, right? Formula, and I'm using the one with plus in there, right? Tangent, I'm using one with plus. So this says tangent alpha plus tangent beta, right? So we go tangent, alpha for us is theta, right? And then plus tangent of what? Pi over 3. And then over 1, and then minus tangent theta times tangent of pi over 3. Do you know what tangent of theta is? Yes, it's √21/2. Right, so you put that here, you put that here. And then do we know what tangent of pi over 3 is? That's a little harder, but let's see. At pi over 3, you're here, right? That's the point 1/2 here, right? X coordinates 1/2, and then √3/2. By definition, tangent is the y divided by the x. So √3/2 over 1/2. Flip, keep dot flip, and you should get √3. So I'll do one more step. I won't go any further after this. So tangent of theta was √21/2 plus tangent of pi over 3, which we just said was √3, over 1 minus tangent of theta, which we said was √21/2, times tangent of pi over 3, which we just said was √3. There. I'll leave it like that. If you get me that on the test, I'll be happy. All right, because the rest is just cleaning it up. All right, more problems for us here. This one's going to be a little different, all right? Especially the way it's worded. Let f of x be cosine of x. Find f of alpha plus beta given the following. Right, this is weird. I mean, I know it looks strange, but I'm telling you I have a function, the cosine function. And what I'd like for you to do is plug into that function alpha plus beta. So instead of plugging x into this, I want you to plug in alpha plus beta. And tell me what the answer is. And I'm going to give you this information. And the information I'm going to give you is two pictures. The first picture is that this point right here lies on a circle, and the point here is the point x, comma, -1. Okay, I'm giving you the x coordinate. You don't know what it is. The y coordinate is -1. And I'm giving you that this, you see the circle I just drew? I'm going to give you the equation of that circle. X squared plus y squared equals 4. That's the equation of that circle. Oh, and I need to label that. That's alpha. This is the angle alpha. Draw it, and then I'm going to draw the other one. We'll talk about what we have here. All right. The other one is a different circle. And I have a point over here that has, as an x coordinate, -1/3. And the y coordinate I'm not giving you. I'm telling you the equation of this circle is x squared plus y squared equals 1. That's all I'm giving you, right there. Oh, no, I'm missing one thing. I need to tell you that's beta, sorry. This is the angle beta. So take a moment to copy that down. Let's first wrap our heads around what we're being asked. Again, f of x is cosine x. I want f of alpha plus beta. That means plug alpha plus beta into this function. So this means I want cosine of alpha plus beta. Do y'all see that that's just kind of like a fancy way of asking you what is cosine of alpha plus beta? Is by calling cosine of x, calling that the function f of x, and then asking you to plug alpha plus beta into that. It's just a complicated way of me asking you that, yes? So what is this? Well, we have a formula for that, right? The formula we have for this, we know, is cosine alpha, cosine beta, minus, right? Sine alpha, sine beta. So I need to figure out all of these values, cosine of alpha and beta and sine of alpha and beta. And this is the information I have about alpha and beta right here, these pictures. Well, in order to figure out what sine, cosine, tangent of alpha are, I need to know x, y, and r, don't I? Well, I know what y is, right? They gave me that? They didn't give me x. Did they give me r?
Yes.
How did they give me r?
On the equation you said,
This is a circle, right? Hold on, this is a circle. Do you remember in the beginning of this class, right after we did partial fractions, we did circles? And that's the generic equation of a circle. The radius of this circle would be what? What though?
Square.
What would it be for this circle?
4.
Nope, not quite, not quite. Remember, the generic formula for a circle is this. X squared plus y squared is r squared, right? So the number over here is the radius squared. So the radius is 2. The radius of this circle is the square, that right there is our radius squared. And that means that this point lives on this circle of radius 2. So that tells us that r is 2. Understand? Just so we're clear, if I gave you this circle, What's the radius of this circle? 3, right? Okay. What's the radius of this circle? 1. So we know that this right here, r is 1. So on this one, for beta, I know r and I know the x coordinate, right? But I don't know y. Here, I don't know x, I know y, and I know r. So once you have these, we can do 2 Pythagoreans, can't we? And we can figure out what x is over here and what y is over there. Once we have that, we know sine and cosine and everything else. So again, these were kind of like 2 problems here. On this one, let me set it up. It would be x squared plus the y coordinate negative 1 squared must equal 2 squared. So x squared plus 1 is 4. So x squared is 3, which means x is plus or minus root 3. Which one is it? Minus. Because? You're in the 3rd quadrant. So this is going to be negative root 3. The x coordinate is negative root 3. So we have to go over and down. Over here we do the same thing. We have x squared, but x is negative 1/3. That's squared plus y squared equals the radius squared. Hey, what's negative 1/3 squared? 1/9. 1/9 plus y squared equals 1. Subtract a 9th on both sides. What's 1 take away 1/9? 8/9. Right, you need a common denominator, 9/9. Subtract 1/9, that's 8/9. And now take the square root. Plus or minus, right? Square root of 8/9. I'm going to rewrite that as square root of 8/3. I'm doing that only because 9 is a perfect square, so I do the root of top and bottom separately. Oh, and is it plus or minus? The plus because we're up there in the 2nd quadrant. So this y coordinate is root 8/3. How are we doing? Good? Yes?
Can you go back over how you got 1/9? Sorry.
I got 1/9 or 8/9?
1/9 in the beginning.
Squaring this,
Oh,
right? So when you square that, negative 1/3 times negative 1/3, that's what it means square. You go straight across, so you go 1 times 1, you go 3 times 3. This is actually, there's a little off topic here discussion we can have. Most people think that, if I say, hey, take a number and square it, right? Most people will say, hey, yeah, the number would get bigger, right? When you square a number, it gets bigger. That's not always the case. If you take a fraction, like 1/3, and square it, it actually gets smaller, doesn't it? So it kind of depends on the number. You can't make a general statement that anytime you square a number, it gets bigger. That's a conversation for calculus. We'll have that conversation some other time. But all right, we good? All right, let's just set this up. Can you tell me what cosine of alpha is now? Well, here's alpha, right? Cosine is which coordinate over which coordinate? X over r. Here's x, and r was 2, right? So negative root 3/2. That's this. So this is negative root 3/2 times cosine beta. So now we go to this picture. The x coordinate was negative 1/3 over what? 1, which is just negative 1/3, minus sine of alpha. So we go back to this picture. Sine of alpha is the y coordinate over r, so negative 1/2, times now sine of beta, that's the y coordinate over r, right? This over 1. So just root 8/3. Put these two together. That's root 3/6. Minus minus is plus. Root 8/6 again. And then you can put those together. Root 3 plus root 8. Cannot combine those together, right? Those are apples and oranges. So you can't combine them. How y'all feeling? It's okay? Okay.
We couldn't combine those two things the same denominator.
What do you mean? Like combine those?
Yeah.
Is that what you're asking?
Yes.
They're not what we consider like radicals. To be like radicals, whatever's underneath the radical has to be exactly the same. So if I have let's say I have root 3 and I want to add to it root 3, then yes, that would become 2 root 3s. It's like an apple plus an apple is 2 apples, right? You can do that. But if you do root 3 plus root 6, that can't be added together. That's what I was saying. This is like an apple and an orange. If it's multiplication, that's different. Then we're not talking apples and oranges anymore. Because multiplication, that would become root 18. Then you can multiply the two numbers together, but you have to have multiplication for that. Okay? These are good questions, right? I mean, there's always a delay when you're learning math, right? You finish algebra, you pass algebra, you get through it, and then your algebra starts to get better as you get further along. You take calculus, you're like, okay, I passed calculus, and then you really don't truly start understanding it until you get into Cal 2, and then you're like, oh, okay, now I get what we were doing in Cal 1. There's always like a little delay, so all these little things from the past, we try and kind of get better and better with them as we go on. All right, you ready for this? Here we go. Show that sine of alpha plus beta minus sine of alpha minus beta equals 2 cosine alpha sine beta. Ooh, does that look familiar? That's an identity. We're being asked to verify an identity. You thought it was over, didn't you?
Yes.
I want us to show that this is true. Which side would you like to start with? Left, right? It looks more complicated. And don't we have formulas for those? Yeah, we do, right? So I'm going to start with the left-hand side. Hey, before I continue, let me make sure I wrote it down properly. Tell me how you really feel. All right, start with the left-hand side, right? So I'm going to rewrite this using the formula, right? That becomes sine alpha cosine beta plus cosine alpha sine beta. All right, and just so we're clear, this, right, is that, right? Then I have minus, right? Minus. Now, when I subtract this, remember, this is going to turn into a bunch of crap over here, right? And there's actually going to be two terms, right? This turns into two different things. So I'm going to need a set of parentheses for that negative sign to distribute. What is this? Forget the negative. What is that right there? The formula for that. Sine alpha cosine beta minus cosine alpha sine beta, right? Very important that I have that set of parentheses around that, right? This is that, right? That's what that is. Now let's distribute the minus sign through. Let's just distribute this through here and here. So we'll get sine alpha cosine beta plus cosine alpha sine beta minus sine alpha cosine beta plus cosine alpha sine beta. All right, so it makes this minus and it makes this a plus. Do y'all see it? What happens now? Something goes away. What goes away? sine alpha cosine beta cancels. And I'm left with cosine alpha sine beta plus another cosine alpha sine beta, right? So that's two of them. 2 cosine alpha sine beta, which is the right-hand side. Yes. Shall I do another? We'll do one more.
You made that one seem nice. I feel like this next one.
The ones that are here in this assignment are not too bad. Actually, let me pick a different one.
After the next one, do you think you can go over one of the questions?
After the next one, it depends on the question. Give me a minute. Let me do this one, and then I'll look at what you're talking about here. All right, here we go. Show that cosine of alpha plus beta over cosine alpha cosine beta equals 1 minus tangent alpha tangent beta. Do you have the one that you're talking about?
Yeah.
Which one is it?
23.
Okay, yeah. All right, you ready? Which side do you want to start with? Left? Okay, and that's mostly because we have a formula for cosine of alpha plus beta, right? Like we have that formula. So starting with the left-hand side, I'm going to rewrite the cosine alpha plus beta using the identity, or the formula. So cosine is cosine alpha cosine beta, but then it's minus sine alpha sine beta. But it's all of that divided by cosine alpha cosine beta. There we go. Questions there? Yes?
Is